Experiment of shear force at the section XX. Apparatus used is STR3 shear force in a beam, as shown in this diagram. The simple beam is supported at two pivots at support B and C. The beam has a cut at D. A cut mechanism is used to stop the beam collapsing and allows movement in the shear direction only. An electronic load cell measures the force and connects to a digital force display as shown in the picture. The digital display will show the value of shear force at cross-section XX when the load applied on the beam. The digital display must be ensured to have a value of 0 before the start of the experiment. These are hangers and masts that are used as loads applied on the beam. Free body diagram of this apparatus is shown in the picture. The first experiment is to determine shear force variation at a cut section due to variation of loads and load positions. We have three cases of experiment. The first one is by putting a load between span AB and determine the shear at section XX. Three different values of load are used in this experiment. For the case 1, the first is at 100 mm to the left from B support. The first load for this experiment is 100 grams, and when the beam is applied with this load, shear force happens at the cross-section XX, and it is displayed by the display digital. The digital display recorded minus 0.02, and this must be multiplied by minus 1 to get the value of shear at the cross-section XX. The data obtained will be recorded in the data sheet and will be compared with the theoretical value later. For the second trial, in the case 1, it will be 200 grams, and the same procedure is repeated. The digital display shows the value is minus 0.4 Newton, and the value of the shear at cross-section is 0.4. The third trial is when P is equal to 300, and we have the Vxx is equal to 0.6 Newton. All the data obtained from first, second, and third trial are recorded. From this data obtained, one can see the variation of V at cross-section XX due to variation of load. Next is case 2, where the load are positioned at B and D. Three values of load are used, that is 100, 200, and 300 grams, and each of them are recorded the value of the shear at cross-section XX. The load are applied at 140 mm away from support B. The data obtained from this case are recorded in the data sheet. For the third case, the load will be placed between D and C with the same amount of value as before, that is P equal to 100, 200 and 300 gram, and the same procedure are repeated. The data are then recorded in the datasheet. From these three cases, one can observe the variation of shear force at XX due to variation of loads and variation of position of loads. This data set also can be used to obtain the negative and positive shear force as required by the objective number 2.